We're going to use a Casio calculator to work through the first example in Chapter C10. The question is about the height of projectiles, and it is very strongly suggested that a quadratic model will be appropriate. In order to do this calculation, choose the statistics module, so that's number 2. I've already entered in list 1 the times, and in list 2 the heights recorded for the first of the projectiles. It's important to check that the calculator is set correctly, that is F6. Our X list is list 1 and our Y list is list 2, so the calculator is going to be looking in the right place for the data. I will exit from that screen, and by choosing F1 we can graph the data immediately. And what we see here is that the pattern is very strongly suggestive of a parabola, and hence it is very good that we will be looking for a quadratic model. In order to work out what the quadratic model actually is, choose Calc, and of all of these options here, we've already seen the linear regression module. Choose x squared, you will get the calculator trying to fit a quadratic. So I'll press that, and what we get is we get the announcement that the calculator is trying to find an equation of the form y equals ax squared plus bx plus c. And what it's done is it has found that a will need to be -5, b will need to be 18, and c will need to be 1. This figure here, we should be familiar with that. That's r squared, and that measures how well the model fits the actual data. The closer to 1 this gets, the better the fit. This is the same as it was with the linear regression examples, and we can see now that this model is a very good fit to the data. MSE stands for mean standard error, mean square error. What the calculator has done here is it has taken all the errors, the difference between the actual data and the model, and it has squared them to get rid of the fact that some of them are positive and some of them are negative, added them all up and divided by the number of data items. The value of 0 here, of course, indicates that we've again got a very good fit. Draw will show the whole thing on a graph. And so what we've got here is we've got a quadratic model fitting these data perfectly. Doing the same thing using a Texas calculator, I've opened a page from the spreadsheet and lists type. I have entered the data for the times and the heights of the first particle, much as I did on the Casio calculator. It's a good idea to give labels to these, so I've labelled column A time and column B height. The next thing I'm going to do is I'm going to insert a statistics page, a data and statistics page. This will help us show the figures graphically. I've got to tell the calculator where to find the data though, so I'm going to click on the X variable, and we will want that to be time. We will want the Y variable to be height, and there we get a very nice picture of the data, and as before, it's very strongly suggested that this is going to be a parabolic model, and so quadratic regression is a sensible option. So I'm going back here and I'm going to insert now a statistics calculation page. So statistics calculation, and I'm choosing quadratic regression. Once again, we've also got to tell the calculator where to find the data. So the X data will be time and the Y data will be height. OK there, and we get our regression output. So I just need to move across and we will see the figures that we need. So as before, we've got A is -5, B is 18 and C is 1. Our R squared is 1 and the residuals are a list of the errors that have been made, and you can see they're all 0. Returning to a Casio calculator and looking at the data for particle number 2, I've entered the second set of height data in list 2. I'm going to repeat the process that we've been through before, so we will graph the thing first. I don't need to check the setting again because that was correct. And this doesn't look terribly different, but there is a little subtle difference here that we'll see in a second. If I type calc now and choose the x squared option for quadratic regression, we will see that we get a very similar set of A, B and C, but they're not exactly the same. The reason is that we've got some errors built in here. They're not very large errors, and you can see that the fit is still really quite good here because R squared is very close to 1, and the mean square error is now no longer 0, but it's not a large number, so we could be pretty confident that the model is going to fit the data well, and we will see that when we draw. The line does not hit all the data points exactly, but the model is good and we would be pretty confident about advancing it as a solution to the problem. I've edited the data to represent the data for particle number 3. There's one time missing, but that doesn't matter at all. We'll now look at it as a graph, and you can see it jumps around more. The shape of a parabola is not as obvious. If I choose calc, we will see this in the statistics, so I'm picking quadratic regression again. Our A's are not terribly different, but they're not the same as before. And notice that R squared is now 0.96. This is not a disastrously bad value, but the calculator output clearly indicates that our fit is not going to be as good as the two previous examples. The first one was a perfect fit, the second one was a good fit, and this is a reasonable fit. We'll see this if I choose draw, and this time we're basically following the pattern of the data, but missing some data items by significant amounts.